What is up? Okay, so now we're on to 2.4. This is the last section you have to watch this week, hopefully, if you're on time. So in 2.3, we talked about different ways we can write a line. I said my favorite was y equals mx plus b, which is point-intercept form, but we also talked about horizontal and vertical lines and um, why it's important that general form exists so I can express both of those lines in general form. So now we're going to talk about different types of lines. Usually when I teach this section in the fall, it's during Halloween, so there's going to be lots of spooky things in it. So where is my color of the day? There we go, maroon. So if we vary the constant coefficient, right, parallel lines. So first, what's a coefficient? So the coefficient of a linear equation y equals mx plus b are m and b. The constant coefficient, I just would have called that a constant. A coefficient in my mind just goes in front of a variable. And the so the constant coefficient is b, and the coefficient of x is m. Constant coefficient is b, so no x involved, right? That's what would be a constant coefficient, or in other terms, just a constant. And then a coefficient of a variable is that number that's out front. So in this case, the coefficient of x is m, because that's the thing in front of x, that number. Okay. So we're going to sketch the graph of y equals b plus 2x for b equals -1, 0, 1, 2, and 3. So all those different b's. So just to keep my life a little bit easier, boop, we're just going to kind of look it down here. So that's b of -1, 0, 1, 2, 3, 4, and so on, right? So 1, 2, 3, 5. And this is where a beautiful rainbow will happen. All right, so when b equals -1, its slope is 2. So rise over run. So I'm going to rise up 2 and run over 1. Oops, that's not the line that I want. Did that make a line? Right, so that's going to be b equals -1, 0. These are like not being how I want them to be. Okay, this is annoying me. That was when b equaled 0. Let's do another fun color. Let's do this green. So this is when b equals -1, and then the rest would follow. Or sorry, b equals 1. Right, and then we could just keep going. This would just keep going. Like this purple line, and so on, right? So even though I'm changing the intercept, these lines are just kind of chilling out next to each other, right? So, oh, I do love this section. 2.4, it's a very good one. Do we think that these lines are ever going to intersect? Nope. And we'll talk about more of that later. These lines are never going to intersect because they have the same slope but different y-intercepts. It's a different thing if the y-intercept is the same. So always watch out for that. All right. So two vertical lines with slope m1 and m2 are what is called parallel if and only if m1 and m2 are the same. They equal each other. So m1 equals m2, right? So, oh yeah, this is where my pumpkins come in. If let pumpkin be a line. So basically there's a line and named a pumpkin. With the equation y equals 4 minus 3x. Find the equation of the line that is parallel to pumpkin passing through 2, 0. So the line is parallel. So it's going to have the same slope as pumpkin. So m is going to equal, don't forget that negative, it's going to be -3. I'm not told how I want to write the line, so I'm given a point. I'm told it's parallel, so I'm to that line, and I know that I can easily find the slope of that line. So let's just do point slope form, right? So it's going to be y minus 0 equals -3x minus 2. And if we wanted to, we could fix that, and I get y equals -3x minus 2. And that is my equation, right? Beautiful. And again, I know that the slope is -3 because the equation I'm given, its slope is -3, and they're parallel, so their slopes are the same. Okay, so, oh, I love the train problem. So two trains are headed north along California's coast on the same track. Ooh, dangerous. But they're both heading north. They're going the same way. So the first train leaves Solona Beach, 25 miles north of San Diego at 8 a.m. Oh, God. So the second train leaves St. Clement, 58 miles north of San Diego at 9 a.m. Each train maintains a constant speed of 80 miles per hour. All right, so for each train, find a linear equation that relates its distance y from San Diego at time t. So let's call t equals 0 8 a.m. Okay, just to keep everything linear. Just like that problem we were talking about where like I think noon was when x equals 0. Okay, so the same premise. Okay, so train 1, I'm told at 8 a.m. So that's at time 0. It's 25 miles north of San Diego. So its distance, it's y is the distance from San Diego. So that would be 0, 25. Great. So that's train 1, and they're both going at constant speed of 80 miles per hour. Remember when we talked about average speed is a special case of average rate of change? So speed and rate of change are the same thing, really. So, and since they have a constant speed, constant rate of change, our rate of change is also our slope. So I'm told basically that my slope is positive 80. It's positive 80 because I'm going north. Okay, I'm so sorry. Okay, so sorry. So with that, I can point slope form, right? So y minus 25 equals 80, x minus 0. So let's call it 80x, right? Because it's supposed to be x minus 0, but we're just kind of saving ourselves some time by rewriting it. Okay, and then train 2, at 9 a.m., so an hour after 8 a.m., what time? That would be, oh yeah, t equals, oh careful, there's no x here, it's only t's, so that's a t. That's something to watch out for. And then, so at 1 o'clock, 1 hour after 8 a.m., it's 58 miles. Okay. And again, our slope is 80. So this would be y minus 58 equals 80. Not, I know you might be thinking, like, why is it not x? It's just because I'm told that it's in time t. So our input variable, our independent variable is t instead of x. Okay, so t minus 1. Okay. And to make sure that these are truly parallel lines and not the same lines, we might want to go ahead and figure out if they're truly parallel lines. Okay, so, ooh, my nose. If I made, so y minus 25, because if they're the same line, they're going to intersect the entire time. Does that make sense? It's the same line. If I'm myself, I am myself all the time. I hope that makes sense. We'll talk more about intersections, I think in 2.5 or 2.6. 80t would go to y equals 80t plus 25 and y minus 58 equals 80 t minus 1, which would be y equals 80t plus, I don't know, minus 80t. Distribute to the negative 1 plus 58, which would be minus 38. Let me see. Or no, minus 22. So since these trains have the same slope and not the same y-intercept, they are parallel. Since they don't have the same y-intercept, right? So y1 and y2 are different ones. They will never touch. If they have the same y-intercepts, they're the same line and they're always going to touch. So since the slopes are the same and let's see, but y-intercepts are different. That means, like, we could call this one y1 and this one y2. We could say that y1 does not equal y2, so they're never going to be the same line. So they are parallel. And will never touch. So no, they will not collide. Okay. So now let's talk about kind of the opposite of parallel. So now I want to kind of just talk about the coefficient of x and varying that, right? So two non-vertical, that's not really how you spell non-vertical, but two non-vertical lines are perpendicular. Perpendicular, right? Which just means you form a 90-degree angle if and only if the slopes are negative reciprocals. The reason that they can't be vertical is, remember, non-vertical lines don't have slopes. So you can't divide by a slope that doesn't exist, right? So I have m1 equal to negative 1 over m2. So why is there a negative sign? So let's look at, why isn't it just the reciprocal? So if I look at just, let's look at the slope of 1, really. So this is a slope of 1. Well, so if I call M1 1, then M2, well, if I just did 1 over 1, that would also equal 1, which that's the same line at that point. That's not gonna, or it's a parallel line. So if I need a negative there so that it allows me to make that perpendicular line. Because if it wasn't, it would be the same line. Perpendicular, not perpendicular. All right. And also you can see that if one line is increasing, the other one has to be decreasing. And that's what makes that perfect 90 degrees. So that's why that negative sign also needs to be there. Okay. Sometimes people just tell me that I'll ask you guys like, what's the relationship between slopes of perpendicular lines? And someone's like, oh, they're reciprocals. That's not entirely true. Some people could say they're opposite reciprocals, which doesn't really make sense to me. What does opposite mean? But like they're negative reciprocals, okay? Try not to use the word opposite. I think it's weird. Okay, I need to sneeze. 1 second. I don't want you guys to hear me sneeze on camera. Sneeze, which is frustrating, but I'm back. Okay. So moving on, talking about examples of perpendicular lines. So now again, I would have taught this in October. There's switches. All right, so let which be the line with the equation y equals 2x minus 6. Find the equations for the lines that pass through 2, 0 and is parallel to which, and for the line that passes through 2, 0 and is perpendicular. So we have y equals 2x minus 6. So let's do which one passes through 2 and is parallel. So, oopsies. Let's do a parallel line first. So for this one, we know that our M is 2. So for parallel, let's call that M1 would also be 2, right? They're parallel, so they're going to be the same. So Y1 would equal 2x. Oh, let's do point slope since we're given a point. So Y minus 0 equal 2x minus 2. So Y equals 2x minus 4 if you wanted to. Oh, Y1. That'll represent my parallel line. And then my perpendicular line, perpendicular. That slope we'll call M2. And that's going to be negative 1 over M, which is going to be negative 1 over 2. And then we'll also do point slope form. Given a point, found the slope, point slope form. So we're given y minus 0 again, negative 1/2, x minus 2. And if we wanted to, I get y equals negative 1/2 x plus 1, because negative 1/2 times negative 2 is 1. And that both of these are valid too. It doesn't matter. We're not given a certain way to write the problem. It's just because I don't like writing y minus 0. I think it's silly. So I just also distributed the slope. Oh, and we're going to call this guy y2, just so they're a little different. Alrighty. The reason I'm not doing it for x is just because it's kind of like calling a function g of x and h of x. I'm not going to call it like g of y, h of x, like two different things like that. I just want to make sure that you know my outputs are going to be different, and I'm just calling them a different thing. Okay? Beautiful. Absolutely gorgeous. Okay. I think perpendicular and parallel lines, you are given two formulas for it. So you're now just adding on to the three forms of writing a line that we have to now being able to take a given equation, find its slope, and then you're going to be able to find parallel lines and perpendicular lines for it. Okay? So modeling direction proportionality. So that sounds crazy, in my opinion. So we say that y is directly proportional to x if y equals some constant k times x, right? So y equals k times x for some constant k, and that constant k is called the constant of proportionality. Proportionality. So basically what's happening, is I just don't have a y-intercept. That's it. Oh, I do. It's 0. Um, so now my y-intercept is 0. So I'm just going to multiply x by a number, and that's going to be my y. All right. It's called directly proportional to it because x is a proportion of, y will be a proportion of x directly. So if there's like a plus a number, it wouldn't be as direct. Okay. Like, that's how I think about it. Okay. Powering through. This is our last problem. So a solar electric company installs solar panels on roofs of houses. So nice of them. A customer is informed that when 12 solar panels are installed, they produce 2.4 kilowatts of electricity. All right. So that gives me a point. 12, 2.4. And then if electrical output is, and this tells you which is your x and which is your y. If electrical output is directly proportional to the number of solar panels, find the equation of proportionality. That sounds like a lot of big words, but let's go look at the definition. We say blank is directly proportional to blank. So that first blank is going to be your y. So electrical output is our y to the number of solar panels. That's x. So electrical output equals some constant k times number of solar panels. Which it makes sense, right? If I don't have solar panels, I'm not going to gain electrical energy from the sun. Makes sense to me. So right, so our y would be electrical output. We don't know what k is, and we just x. In this case, you're like, Minzy, well, how am I supposed to find k? I'm only given that 1 point. I can't find the slope of just 1 point. You don't just have 1 point. You have 2. Remember, it's y. You also don't even need those points. But I'm just going to plug x and y. I have an x and y, right? My slope is, what is it, 12, 2.4. I don't need to find the slope because I'm just going to plug it in. We have 2.4. All right, so I'm going to plug into here. So I'll get that 2.4 equals k times 12. So k would equal 2.4 divided by 12, which I think should be 0.2. So my equation would be y equals 0.2x. You're also always given a second point. Like I said, the y-intercept is 0. Since I'm not given, there's no plus b, so plus 0 is the same thing, right? So I'm given the point 0, 0. But we don't really even need to think about that because I have y, k, and x. Well, I have an x and a y, so I'm just going to plug in. I only have one unknown left, k. So I'm going to solve for that. Once I have k, I can plug it back into what I want. Beautiful. So then I can use that to find how much electricity is produced by just 16 panels. So I do y equals 0.2. Remember, the number of panels is my x, 16. And I think that should give me 3.2. So I don't think I'm going to put that. And what is, oh, how many kilowatts? So it already tells me my units. I don't even need to scroll back up. Okay. So that's direct proportionality for you guys. It's just a line where it's y-intercept is 0. Pretty fun. Alrighty. Ooh. All right, so we're done with this section. You should be done for the week now. If you have any questions on homework and things, email me, come to office hours, and we'll talk. All right. So I'll see you guys then.